As we study polynomials, and in particular, as we start trying to find roots of polynomials, it's important that we refresh our memories about division. So let's just take a look at how long division is performed. Here we've got 143 divided by 13. Now remember the algorithm here. We take this 13 and we ask how many times will it go into 14? Well, once. And then we want to say, okay, well, what is left over? So I multiply 1 times 13 and subtract it from 14. And that tells us, okay, 13 will go into 14 once with 1 left over. Okay, then we go through the process again. I bring down the 3. 13 will go into 13 once. 1 times 13, it's 13. We subtract, and we get 0. So there's no, so what this tells us is, and this is finished, right? The algorithm here is terminated. There's no more numbers to bring down. And what this tells us is that 143 divided by 13 is equal to 11. Now another way to say that is that 13 is a factor of 143. And in fact, you could multiply both sides by 13 and get 143 equals 11 times 13. And this is the factorization of 143. So notice, 13 goes evenly into 143. That means 13 is a factor. And notice what happens. If you divide by a factor, you get another factor out. Okay, so let's look at this with an algebraic expression here. So we've got x squared plus 4x plus 3. Now notice, that's a lot like 143, right? If x is 10, it's exactly 143, and we're dividing by x plus 3, which if x is 10, that would be 13. So we would expect to get x plus 1, but let's see what happens here. I'm going to take x squared divided by x. So you take this first term and divide it by this first term. And in this case, you get x. I put an x right there. Then I want to say, okay, what is left over? Well, I multiply x times x plus 3. I get x squared plus 3x. I'm going to put it right here and subtract. Now be careful when you're subtracting because remember, you're changing signs and adding. So all of these, you got x squared minus x squared, 4x minus 3x. And you get x. Then you bring down the next term. And this is always the process. You divide, multiply, subtract, bring down. Always. That's the cycle. So now we take x and we try to divide it into x here. See? X will go into x once. So I put that up here. Then I want to see, well, what's left over? So x, 1 times x plus 3. You get x plus 3. Subtract, and you get 0, just like what we did over here. Notice the parallel here. So here's what we know. We know that x squared plus 4x plus 3 divided by x plus 3 is equal to x plus 1. In other words, x plus 3 is a factor of this, of x squared plus 4x plus 3. Or another way to look upon this is we could multiply both sides by x plus 3, and here's what we get. And notice that this right here is the factorization of this. So one of the things that we use division for here is we said, okay, we know one factor. We have one factor. How can we get another one? Well, by dividing. We divided 143 by 13, and we got a factor of 143. See, we divide it by a factor, and we got another factor. That's what this division does. Now, let's think about this. Here, let's just suppose I've got x squared plus 5x plus 6. I want to divide by x plus 1. Okay, let's see what happens here. I take x squared divided by x. I get x. Then I multiply by x plus 1. And I get x squared plus x. Subtract, and I get 4x, and then bring down the 6. This is always the process. This is the algorithm that we use. Then I divide x into 4x and get 4. Then I multiply, 4 times x plus 1, and then subtract, and I get a 2. Now, we're done here. There's nothing else to bring down. This algorithm is terminated. We brought down the 6. There's nothing else to bring down. We're finished. Now notice there's a remainder of 2. So what we found is that x plus 1 is not a factor of x squared plus 5x plus 6. Definitely not. And what we have is this. We have x squared plus 5x plus 6 divided by x plus 1 equals x plus 4 plus 2 over x plus 1. Okay? That, in other words, this side right here is exactly equal to this side. Now, we could multiply through by x plus 1 and get x plus 4 times x plus 1 plus, you notice these cancel, and we get this. X squared plus 5x plus 6 is equal to this product plus 2. Yeah. So this is what happens when you're dividing by something that doesn't go evenly. In other words, you're dividing by something that's not a factor. So let's think about this. Or let's see if we can assign some names here. We've got some function divided by some other function. So I've got x squared plus 5x plus 6 divided by x plus 1. This thing on the bottom here, we'll call that the divisor. Okay, so in this case, x plus 1 is the divisor. And it equals a quotient. Okay, in the case that we looked at, x plus 4 is the quotient, plus a remainder over the divisor. Now notice, this up here, this is the remainder, okay, this r of x. And in our case, r of x was just a constant, it was 2. But you could have a remainder to be something, you know, in terms of x. So I'm just being general here. This is the remainder, okay? Now, we could multiply through by the divisor. And notice what would happen. We would get f of x times f of x over d of x times d of x. The d of x cancels, and here's what we get. And of course, the d of x canceled here. So this is one way we could represent what f of x is. And notice if there's no remainder, then f of x would have a factorization to just be q of x times d of x. Okay, so here's what we have up here. Now let's take note of something interesting here. F of x is equal to this right here. It's the same thing. Now, up here, I divide it by x plus 1. Now, watch this. I'm going to plug in a negative 1 in here. I divided it by x plus 1 here. Let me, instead of x plus 1, let me just take the negative 1. And I'm going to put it in for f of x. Okay? Now, look what happens here. I put a negative 1 here. I get negative 1 plus 4. Put a negative 1 here. I get negative 1 plus 1. That's 0. So this whole part here goes to 0, and I'm just left with 2. Now notice that's exactly what the remainder was up here. Okay? In other words, when I divide it by x plus 1, the remainder that process yielded is exactly the same as evaluating the function at negative 1. So look, x plus 1 divided into this, x squared plus 5x plus 6. The remainder is what I would get if I, instead of dividing by x plus 1, if I plugged in the negative 1 into the function. So that's a cool thing to take note of. In other words, look at this. Just to be general, we took this function, f of x, which in this case was x squared plus 5x plus 6, divided by x plus 1. I'm just going to put it generally as we're dividing by some x minus c. In this case, c was negative 1. See, x minus a negative 1. So we get x plus 1. So look, I've got f of x divided by x minus c. Now that equals a quotient plus a remainder over x minus c. Okay, so what I've done is I've just kind of generally set up this situation up here. Now, if I multiply through by x minus c, like I did, over here, look what I get. I get f of x, which this is f of x, equals the quotient, right? Here's the quotient, times the divisor, right? Here's that. X plus 1 here, that's x minus c here, plus the remainder, that's the 2 here. Now, okay, so in other words, this is what I get. Now, watch what happens if I try to evaluate this function and find f of c. See, I divide it by x minus c. Look what happens. If I plug in a c, I get q of c times c minus c. There's 0 plus r. So it's just equal to r. So that's a cool thing that we can just pause and take note of here. If I'm dividing by x plus 1, the remainder that I get, the numerical remainder, is the same as if I'm evaluating the function at -1. If I divide by x minus 5 and I get a remainder, that remainder will be the same as the function value if I plug in f of 5. So that's just something interesting to note. The remainder is the value of the function evaluated at, x plus 1, you evaluate at c, let's just say. Okay. So in other words, it's going to be the opposite of what you see here. If you see x plus 1, that's the same as plugging in a -1. If you see x minus 1, the remainder is going to be the same as if you plugged in a positive 1. So anyway, that's something to take note of. So let's suppose we've got this function here, and let's just explore it a little more. We've got f of 3. Now notice, if I plug this in here, I've got 3 squared minus 3 minus 6. Well, that's going to give you 0. Now let's just take a minute and dig this. I plugged in a positive 3 here. Now let's see what happens when I divide by x minus 3. See, the signs are different. Well, x will go into x squared, x times. Then I multiply. See, x times x minus 3, I get this. Subtract, I get 2x, bring down the -6. See, negative x minus a negative 3x will give me a positive 2x. Now, x will go into 2x 2 times. I multiply, 2 times x minus 3, and then I subtract, and I get a 0 remainder. So notice f of 3 is equal to 0. Likewise, the remainder here is 0 when I divide by x minus 3. Okay, so let's take a minute and see what this says. Notice the fact that f of 3 gives me a function value of 0 means that 3 is a root. Okay, 3 is a root. And x minus 3 is a factor, because notice x minus 3 divides evenly into this. So 3 is a root, then x minus 3 is a factor. That's a very important relationship. If f of c is 0, then x minus c is a factor. Now let's try this, f of 5. So I put in a 5 up here, and I get 14. And you can check that out if you want. But if you put in a 5, you get a 14. And then let's look what happens when we divide. X will go into x squared, x times. Then we multiply, x times x minus 5. Get this. Subtract 4x. Now bring down the -6. And x will go into 4x. And then multiply. Okay, see, I multiplied, and now subtract. Okay, now notice I get a 14. Look at this. F of 5 is equal to 14, and when we divide by x minus 5, I get a remainder of 14. Those are the same. Cool. Okay, cool. There we go. Okay, now let's continue this discussion. Let's suppose that I know that x minus 1 is a factor of x cubed minus 1. In other words, I know this, that if I divide x cubed minus 1 by x minus 1, I get a 0 remainder. I know that. So x minus 1 goes evenly into x cubed minus 1. Now let's see what the other factor is. So I set up a division. Now here's the thing. Whenever we're dividing, just so that we keep everything in place, so that we don't end up with a mess on our hands, what we do is we don't skip powers. So I've got x cubed minus 1, but I don't have an x squared, so I just put a 0x squared. I don't have an x in here, so I just put a 0x. This makes it so that everything is a little more structured and lined up. And it helps us hopefully not to make errors because things are out of place. So now let's divide x into x cubed. Well, we get x squared. Then I multiply. X squared times x minus 1. Now you can see this is cool because this is lined up, right? We have a 0x squared right over an x squared, so that's nice. And then we can subtract, and we get an x squared. See? This goes out, and then 0 minus a negative x squared, I get an x squared. Now I want to bring down the 0x. And I say x into x squared goes x times, multiply. And I get x squared minus x. Subtract, and I get x. Now I want to bring down the negative 1 and divide again. X will go into x one time. 1 times x minus 1. And notice I get a 0 remainder. So here's what we've got. X cubed minus 1 divided by x minus 1 is equal to x squared plus x plus 1. Yeah. So it goes evenly. So we've found another factor. Now if I multiply through by x minus 1, I get this. X cubed minus 1 is equal to x minus 1, x squared plus x plus 1. So we've discovered a way that we can factor x cubed minus 1. Now as a matter of fact, while we're here, we might as well just take note. This is how we find the difference of cubes formula. So if we had x cubed minus a cubed, like here is x cubed minus 1 cubed. This is the formula for the factorization. It's sort of like difference of squares. It's x minus a times x squared plus ax plus a squared. It's just something to take note of. The important thing here is that if we're given a factor, we know how to find another factor. And notice, if x minus 1 is a factor, then x equals 1 is a root of x cubed minus 1.